Hello guys, how are you doing? Can you hear me? Okay, I can see myself. We will go over the third one initially. Most of us wants the even small walkthrough will work. Uh yeah, sure. I mean, I shared the full editorial of the contest in here. Guys, this is something that we used the editorial that we wrote, but at the end, because I had to come to the live stream very soon. I had to have several AI agents to go over them and fix any grammatical errors and everything. So definitely let us know if anything is problematic. But so far we believe that everything is good. I mean, and I was an author of today's contest. I was mentioned as an author, but I honestly myself, this is a contest that we started 2 years ago discussing about them with Amir Reza and Parsa. And after that, I was very less involved in it. So I thank the guys for still putting my name as one of the authors, but I did not attend the meetings at least in the last year. But I'm very thankful for them, and I see that finally see that the problems that we discussed back then are used in a contest. I mean, I'm glad because I was. I mean, I should thank them for continuing this. Anyway, so if you're ready, we can start talking about the problems without losing any additional time. We possibly go over the first few solutions. I mean, probably till problem C or D, and the rest of them, as you know, are on the editorial. I say that because I want to also get back to the editorial as well and ensure the correctness of everything and make sure that everything is are great. So, without losing any additional time, I think that we can. I'll send you the link to the editorial again. It is pinned as well. And you want to take a look at the solutions of all the problems. You don't need to wait for. And guys, we implemented it in a way that it gives step-by-step solutions. So let me go into my screen. If you open it, it's pinned here. We made it step by step. You can also enter focus mode, and you can go over the problems in each problem step by step. It will tell you the solution, for example, the hints, and then the approach. So you basically and the complete examples and walkthroughs, and at the end also the time complexity and everything. So we have discussed everything. This is actually still in experimental mode. We have to make more sure about that all our system is working very perfectly to make it better. I mean, your feedback can be actually super helpful on improving the editorial. So I'm just curious, you haven't, that's it. Pretty unbalanced problem says. Okay, so let's start talking about the problems. Let me bring the problem A and start discussing it. So, this is the problem A carnival wheel, and it says that you have a prize wheel divided into L sections, number from 0 to L minus 1. The sections are arranged in a line, so after section L minus 1, the number continues again from section L. The point is that the price pointer at the beginning is at section A, and each time you can add B to it. And you can do it as many times as you want. And each time from from the current position, it will goes to the position plus B modulo L. You have to say that what is the maximum price that you can obtain. So let's talk about this. So let me discuss this problem first. Guys, in this problem, as is mentioned in the editorial as well, the first thing that you should think about is that, I mean, if you have seen these type of problems, you know that when we keep adding something, there's something related to GCD in such problems. Now I'm gonna solve it for you from the beginning so that you can completely understand the solution. Guys, assume that B is even and L is also even. Then assume that you start at position 1. You can easily see that you always remain in odd positions. For example, if B is 2, you go from 1 to 3, and then from 3 to 5, from 5 to 7, and so on. And because L is even when you take modulo, your parity does not change. So if B is even and L is also even, you can easily see that you always remain in the same parity. And this is not just for modulo 2. Basically, if B and L are both divisible by some number D, you can see that your remainder, the remainder of your position by D, never changes. And that's the whole point. So now what is this D? I mean, how can we choose the greatest divisor of B and L, the greatest common divisor of them, that's both B divides that and L divides that? That's just the GCD, right? That's the definition of GCD, the greatest common divisor. So you have to calculate the GCD of B and L, and then you can be sure that your remainder of your position by D will never change. And then you can see all the positions that are that value modulo D and take the maximum of them, and that your answer will be that at the end. Is it clear? If it's clear, please put a plus or use this emoji, 100 emoji. Sure, I'm just curious, you haven't watched your own topic streams to learn concepts. So how did you learn topics? Yeah, actually, not only I haven't watched my topic streams, but the main point is that at the time we didn't have roadmaps. Now you have roadmaps. Roadmaps are, I can tell you the roadmaps are the craziest way right now to learn everything in CP. I mean, I can tell you with confidence. I mean, the reason that it is taking so much time for us to release everything, if you remember at the beginning, I was saying that in 3-4 days we will release all the roadmaps. But now 15 to 20 days has passed and we haven't released all of them because we're being so perfectionist. But the result was good. I mean, I think that at the end we have a good roadmap at the end. So if you haven't watched that, I mean, first, dynamic programming roadmap is the one that we worked the most on. We are working on the rest now. Me and the people who are working on it, they are really great people who are working on this roadmap. So I think that's the craziest thing that you can learn CP from, and it can level you up, definitely. Okay, so I guess problem A is completely clear. Okay, binary search. I can add binary search to the roadmaps, definitely. VIM pressing the S key causes the focus to jump from the... Oh, yeah, that's bad. Thank you for mentioning that bug. We will fix that. Yeah, and I don't know if you've seen that or not, but anyway, in the compiler, we added also VIM modes. So, I mean, it's completely is like VIM. I don't think any website has an online compiler that has VIM mode. I haven't seen. Maybe there is. I haven't seen it. Okay, let's move on to problem B. So, problem B. It's weird why people are still asking questions after the contest has ended. Okay, anyway, so you have an array A of n strings A1, A2 to AN, each consisting of lowercase English letters, and an empty string S. In the ith step, you should do one of the following. Either add AI to the beginning of S or add AI to the end of S. And you have to say that what is the lexicographically smallest string that you can achieve at the end if you do this. So you have to figure that out. Okay. Sir, today you just exposed every LLM coders. Why? How? Can you please explain me which I need to reach? Definitely one of the, I mean, the most important topic to learn is DP. But if you are right a newbie or pupil, don't do that. Just start solving problems. I think that when people start competitive programming, the first thing that they should do is to, after learning the syntax of the language, they should go to Codeforces, sort the problems, solve at least 100, 200 problems, and then we can talk. So the first thing that you should do is to solve problems. So if you are newbie, don't start like, oh, I should learn DP right now. No, first accept problems. I tell you as someone who's been there, right? I mean, 10 years ago, I was exactly in your position. I went to here, and 2 months after that, I was an expert. I mean, from this newbie to expert, it took like 2 months from March to May. In 2 months, I went from newbie to expert. And in 3 months, I went from newbie to rank 4 in a contest. So believe me, it's something that I've done 10 years ago as well. So if I tell you that you should just solve problems at the beginning, I've done it. And for 9 years or 10 years, 9 years now, for 9 years, I'm teaching CP to people. And I've had so many students and I've seen how they did grow. So when I tell you something, that's something really real. If you're newbie, don't start learning stuff. Just start solving problems. That's how you can grow. Anyway, let me tell you the solution to this problem now. So, guys, in this problem, basically, the first thing that you can see is that at each step, we have to keep S lexicographically minimal. So our solution is basically to our solution is basically a greedy solution to keep S the minimal possible value at each step. That's the first step. So that's the first hint. At each step, we want to keep S lexicographically minimal. So that makes the problem very simple. I mean, if you take a look at the constraints, we know that the sum of n over all test cases is at most 1,000, and the total length of all strings in the inputs does not exceed 4,000. So simply what you can do is to just check. Just check that each time you have two options, either add to the end or add to the beginning. See that which one of them is lexicographically smaller, and just use that. And that's going to be all. So that's the solution of this problem. If it's clear, please again put a plus or use this emoji. Should bring binary search next other than advanced topic. Yeah, I mean, in the roadmaps, we will definitely add binary search as well. We have C++, math fundamentals, the math fundamentals that you need. And guys, I don't know if you've seen it or not, but it's interactive. Our roadmaps are not just text. It's interactive. So if you go step by step over them, you see that we have coding challenges, for example, that you should write code to go to the next one. And then it runs, and if it's correct, because otherwise, if it's not interactive, it's just a bunch of text. I believe that you don't learn enough. You should do things in the middle of it. And we have quiz, we have coding challenges, etc. I mean, this is something that really, I mean, we've been very perfectionist, and when we were preparing this roadmap. It is free, yes. Everything on RepoVibe is free. I mean, so far I've done a lot of YouTube videos, a lot of things on community, and everything was free. And it's weird that even though I was someone who tried to contribute so much to the community, etc., there are some people who try to do hatred. I mean, and I sometimes think about what did I do to these people? Honestly, I mean, it's like I just contributed so much to the CP community, and all of that for free. And why should someone have some hatred? I mean, it's not understandable for me. I mean, it's like, when did I do something wrong? You know? But anyway, thank you. Thank you, guys. Anyway, yes. So if problem B is fully Okay, we will move on to problem C now. And I think that, as I said, it's the best if we keep talking till problem C probably. And for the rest, you can follow the editorial step by step as well. And that's actually better too, because you have the chance to think about it too. I mean, the solutions won't be just spoiled for you very easily. And you have this step by step guides in order to see the solutions. And guys, our official tutorial on Codeforces will be posted soon as well. I mean, right now, Parsa and Amireza are working on it. In there, we will also mention that we have this editorial as well that goes step by step. We have implemented some features that we can make it visually better and have some visual stuff in here that makes it better, that we didn't have this functionality on Codeforces. But anyway, I mean, that will also, a short editorial that has the solutions will be uploaded there too. Okay, so yeah, the solutions are the same. The solutions are the same. I mean, we basically have the same solutions, both in the RepoVibe editorial and in the uh, editorial that we have on Codeforces. But the point is that because I had to prepare it very fast, etc., I at the end try to fix all the. I made the tables and try to fix the grammars and everything using throwing multiple AI agents at it to just go in parallel check all of them. I mean, if I just show you my terminal and the way that I'm throwing AI agents at them to fix them, you will see that's what I'm talking about. So that's the only thing that's why we put experimental in here, because we definitely should spend some more time in order to ensure that no issues will happen. I mean, because we try to do it so fast. Okay, so I solved a bunch of DB quiz and all of them were wrong. That's weird. Maybe there's a bug. Okay, we will. I will definitely check it. I will definitely check it. Okay, so let's talk about problem C. The problem C, XOR factorization. It says that Ostad thinks that the usual way of factoring numbers is too mathematical, so he invented a new notion called XOR factorization, which is more computer science-like. For a given integer n, a sequence of integers a1 to ak with ai from 0 to n for all I is called the XOR factorization of n if and only if a1 XOR a2 XOR 2 ak is equal to n. And you are given integers n and k, you have to find the XOR factorization of a1 to ak of n that maximizes the sum of a1 to ak. I mean, that's the whole thing. It can be proven that under the problem conditions, XOR factorization always exists. Guys, in order to solve this problem, you have to be familiar with XOR and how it works. If you're familiar with it, you know that XOR is something that at each bit, if you have odd number of ones, you will end up with a 1 at the end. If you have even number of ones, you will end up with a 0 in the answer. So basically, what we have to do is to just, who was the author of this, you or someone else? No, this problem, I wasn't the author of it. So what we have to do is this. This XOR factorization, the whole thing that it is saying is that at this specific bit, the number of ones should be odd or even. That's the whole thing. So the main points in general is that you can see that at each bit positions, you should see that how many ones we can have there and how it can be exactly in the way that we want, that the XOR ends up to n. That's the whole thing that we have to solve, right? And we want to maximize, just trying to check something here. This stream is gone because I didn't update the time. So yeah, basically now we know that our condition is only this. That's at this position, we should have odd or even number of ones, basically. So when we know this, we want to maximize the sum, right? We want to maximize the sum of A1 to AN. So the best situation for us is that each bit, I mean, for each bit, we know that in the XOR it should be 0 or 1. So we know that even number of numbers should have that or odd number of numbers should have that. We know this, right? Now the question is that considering this, we know that the best possible outcome for us is that it's at some bit all of the numbers have that bit set. So all of them have 1 in that position when we want to maximize A1 to AK. Or if you cannot make all of them 1, we have only one of it to be 0. Because only with making one of it to be 0, the parity will be toggled, right? And this way you can easily find out that, this way you can easily create the sum to be exactly n. And basically you can just set for all of them that n is the same parity as we want. We can make all of them 1. For the ones that n is not as the same as the parity that we want, we make the last one 0. Or in other words, we make the first I mean, that's the best possible way, right? That's the best possible way for us. I mean, I'm ignoring the fact that AI is at most n, but I'm saying that if we had, for example, assume that AI was less than some 2 to the power of k, assume that we were free. I mean, we did not have this condition that AI should be limited. So then it would be as simple as this, right? If you agree with it, please put a plus or use the 100 emoji. So far, I mean, that's the first thing that we have to know. That the first thing is this. We try to maximize the number of this that we have, right? Now you can start from the beginning. Start with the most significant bit. We know that the most significant bit is more important than all the rest, right? The most significant bit is more important than all the rest. So our first goal is to make that first significant bit on in all of them. So first, we start from the beginning and we try to set the most significant bit 1 for all of this. Only if this parity was not matching, we will make one of them to be 0. And we will keep in mind that, okay, for this one, it is 0. And for the rest, we will make it 1. So at each step, only one of them, for one of them, we make it at most 0. And for the rest, it would be 1. And the good news is that if you make it 0 for some number, I mean, this is the most significant bit of n. If you make it 0, then you are sure that this number will be less than or equal to n. So you can be sure about the rest of them, and you can instantly set the rest to be all 1. So as long as you have other numbers that you can fix the XOR with them. So each time you will see that the current bit that you have, you try that, I mean the most significant bit, you try to make it, all of them 1 in that bit. At most one of them will be 0. I mean one of them, at most one of them, you make only that 1 0 to just match the parity that you want for that specific bit. And for that one that you make it 0, you can instantly make all the other bits after it's 1 and just put this number aside. And then continue the process with the rest. You just keep in mind that you have one number like this and all the other bits in it is 1. You just need to make sure that you will have at least one number at the end that you can control the XOR with. And you can ensure that the XOR at the end for all the bits will be okay. You cannot fix all of them and put them aside. Okay, so that's the main points of this problem. I don't know if that's clear or not. Again, as I said, the solutions are here. The solution, I mean, the step-by-step solution is here. And we actually start from hints and we keep going forward from there and discussing about everything that we have. We have we consider basically all the cases and we have example walkthroughs as well. Yeah, okay. Let's consider one example. Sure. Let me make sure I'm on my screen. Okay. Let's consider one example. So let's consider this 5 and 4. N is 5, K is equal to 4. So we basically know that we have to set K numbers and their XOR should be equal to N, and each of them should be at most N. So what we can say is that let's consider the binary representation of N. N is 5, so its binary representation is 1, 0, 1, right? So if we consider the bits of these four numbers, we know that in the first position, odd number of them should be 1. In the second position, even number of them should be 1. And in the third position, again, odd number of them should be 1. So I start with this. I know that in the first position, odd number of them should be 1. And the first bit is the most significant bit. So I start with making, I try to make maximum number of them 1 in the first position at the beginning. Because this way I can maximize those numbers. So for 3 of these numbers, I cannot set all 4 to be 1. Otherwise, this bit, the XOR in this bit would be 0. But I can make 3 of them 1. And only for 1 I can make it 0. So I make it 0, and then I put 1, 1. For this one that I made 0, I put 1, 1 at the end, and I will put this aside completely. So I said that, okay, this is fixed. This is 3. I put it aside. Now I go to the next position. I go to the next position, and I see that basically, okay. There's one thing that I didn't mention. I should mention one thing as well. Sorry. There's one point that I should. I mean, you can see it on this example as well. There's a one. There's one important thing that I also should mention. Sorry for that. If you take a look at this, AIs should be at most n, right? AIs should be at most n. So in the second position, if you take a look at this second position, you cannot put all of, you cannot make any of them 1 because otherwise they will be greater than n, right? Otherwise they would be greater than n. So you should make them 0, but you see that if you make all of these 0, the XOR in this bit would be 1. So what should we do? For the ones that you set, there's also a possibility that later on you decide to change that 1 into a 0. So you can, in this case, you should change this 1 into 0 because you are forced to. Because you have some numbers out. If with the numbers that are still in, you cannot make the XOR what you want, you have to change it for one of those that are outside. So this way, this will turn into 1. Why we made it 1? We initially set it we initially set it to be 3. But later on, we saw that in the second bit, if we have to make all of them 0. But we had 1, 1 from before. And that's problematic because that makes the XOR 1. So that's where we need that and we have to turn it into 0. That's only that you have to add this one simple thing to it as well. And then you go to the third position, you see that it is 1. So odd number of these should have 1. And when odd number of them should have 1, we know that all 4 of them cannot be 1. We know that one of them is 1 and is put aside. And the point is that we can just put 1 in here and put 0 in here. If we had more bits, then we could instantly make everything after it's 1 as well. And then later on, if we needed, we make at least at most one of those ones into 0 if we needed it, like this situation that we have in here. So this way, this number would be 5, this number would be 5, and this number would be 4. And our answer would be 5, 5, 4, 1, or 1, 4, 5, 5 in increasing order. You can print them in any order, but anyway. So this is how we get the numbers. So at each position, we try to maximize the number of ones we have greedily in a way that it matches the parity. And when we put something 0, then we put the rest to be 1. Only there's a special case that if, for the ones that are not fixed yet, we couldn't match the parity that we want because they cannot be greater than n. So the ones that are not matched, they should be at most that bit in n. They cannot be greater. For example, if in n that bit is 0, they cannot be 1. So you should make all of them 0 if in the ones that are matched right now, I mean completely fixed right now, they make the XOR 1, you have to just change one of them from 1 to 0. That's the special case that you need to just change one of them from 1 to 0. Is this completely clear? AIs are at most and at less than or equal to. I hope that this example also made it fully clear. If it's clear, please put a plus or use a 100. Again, guys, I had to make this quick video tutorial of the first three problems. As I said, you can view the rest on editorial because I had some responsibility in this contest. I have to get back to it. So I hope that you, I mean, the ones of you who were looking for the solutions to problems A to C, use that. And the editorials out there, you can comment. And guys, give rating to the problems as well. You can here give rating to all the problems. And that would be definitely very good. And we have discussion as well for each problem specifically, individually, if you had any questions, and we try to answer that. All of this is in experimental mode right now, and we are working on it still to make all of it way better than what it is right now. And gradually, we believe that over time, we make it really something that is awesome. I mean, it's might take some time, but our plan is always to make things awesome as possible. And we are continuing working on the roadmaps as well. I hope that you are getting benefits from the roadmaps. Okay. Shani, is my idea correct? Where did you put your idea? So send your idea and I will tell you what. If n is equal to 6 and k is equal to 2, best answer is to print 3 and 5. My idea was to fix all k minus 2 numbers equal to n, and the last two elements shall be like you talked, but I got wrong answer. I think that also works. That's also an interesting way, and that also works too. That we make n minus 2 of them to be n, and for the last two we control the XOR with them. I think that's also can work too. Probably you had a bug in your solution, but yeah, that looks good. My idea is above. For even k, can't we print k minus 2 n's and find nums whose XOR is n and sum is greater or equal to n? Yeah, the idea of setting k minus 2 of them n is a very good idea. And you can just start from the beginning and just do what I told you with two numbers instead. I mean, at the end, it won't be much different, but yeah, that can also work. Yeah, that also works. Yeah. You can set k minus 2 of them just to be n with the last two, for example, control the XOR. Why we don't say set k minus 1 of them n and control the XOR with the last one? Because if you do that, you might be forced to make this number greater than n. But if you have two numbers, the point is that you can either choose. I mean, you have, these last two numbers. You can see that where do we need to change it, where do we not need to change it. And only for the ones that you need to change it, you can always find one of them that you can set that to 1 so that it won't be greater than n. I mean, so for the last two, you can also initially start them from n and iterate and try to change them. So yeah, that also works. Doing what I said for the last two ones. For Outk, I mean, I think that probably for the last two, what you did is not correct. I mean, maybe you had a bug for the last two. It's looked, like it looked promising to me. It looked like it can work, but yeah, if it didn't work, then no, it doesn't work. The solution doesn't work. Okay, so probably it doesn't work. Maybe we can explore it further if you need. I mean, we are a bit short on time. Otherwise, I would explore your solution further. The idea of setting k minus 2 to n, when I look at it, intuitively looks good. But maybe we have to explore it to see that how you want to work with the last two. Okay, if you want, let's. Problem the idea we have discussed it in the editorial. So we wanted to just quickly talk about the first three problems. It's also pinned here. You can take a look at that. And the editorial on CF is, I don't know what their guys are doing, but they are on it. And it will be released soon. And so if you set the first k minus 2 equal to n, let me think that what you want to do exactly with the last two. It really depends on what you want to do with the last two, actually. I'm thinking about a counterexample that if you set k to be n, the last two doesn't work. Uh, and doesn't make it maximum. If you set the last two to be n initially and start making the changes, yeah, I think that's it's yeah. Now that I think, I don't know. It still seems intuitive to me that you can actually start from the beginning. For 21 out case, the answer is 7, 19. What? I didn't. For n equal to 21, k equal to 4. Oh, yeah, yeah, yeah. You get 21, 21, 21, and 0. Okay, let me see. 21 is 16 plus 4 plus 1, right? And we have three numbers. We have four numbers. What is the optimal way that we can do it? The optimal way that we can do it, you say, is 21, 20, 19, 7. 20, 19, and 7. So, yeah, the XORs look correct. No, but it's still, I think K minus 2 ones can work. K minus 2 n's can work. You can just change it to 1 instead and change this to 0. Just have the number to be 20. 1, 21, and then make this one 18, and then make this one 7. This would also work. So still making k minus 2 of them n works. I don't think that is a counterexample. Last two called A and B, A will take. Guys, it really depends on what you do with the last two. But if you do it correctly, I don't see any obvious issue. Yeah, I mean, we should think more about this, but I don't see any obvious issue in it. We can take a look at the solution of Tourist as well. I think he solved the problem very quickly. So he probably has came up with a easy solution. Which C++ is this? Okay, so it says that if k modulo 2 is 0, if Peter are less than k. Okay, he says that he goes over bits. If n has that bit, he has a pointer. If pointer is less than k, a of ptr plus plus XOR equal to 2 to the power of bits, else a of 0 XOR equal to 2 to the power of bit. Okay, yeah, I mean, I get it. So if he doesn't have enough numbers, he just changes it to a of 0. Otherwise, he starts from the beginning, and for each one of them, go 2 by 2. If it was 0, if this bit was 0 in n. And he chains toggles all the AIs with 2 to the power of bits. I plus 1, he goes to the previous ones. And okay, 2 by 2. Okay. 2 by 2, he tries to add 1 to them. Okay, I think I get it. So he basically is saying that, let me tell you, that's what Turis is saying. So he says that assume that k modulo 2 is 0. Then it means that if we set everything to be 1, that bit would be 0. So when that bit is 1, we should have one of our numbers to have 0 there, right? So basically what he does, he has a pointer. I mean, it's very similar to the solution that I just told you. When you have, he has a pointer, whenever he has to make one of the numbers 0, I mean, when k modulo 2 is 0 and you have some bits, you have to have it 0 in one of the numbers, right? So the point is that he has a pointer that he tries to each time give that 0 to another number. So he has, if ptr is less than k, he will give that 0 to another number this time. Why does he give that 0 to another number this time? Because if you give 0 to a number and that bit is 1 in n, the good thing is that you are free for the rest of the bits for that number. For the rest of the bits, they can be anything and they are still less than n. Okay, so that's the whole point. The whole point is that if you set that to be 0, for the rest of the numbers, they can be anything. So he tries to free up as many numbers as he can. So he says that if ptr was less than k, just make for this one, make it 0. For a new one, make it 0. And then otherwise, he will just toggle it in a of 0 instead. So he tries to just toggle one of them if it's basically at the beginning. If at the beginning, he tries to just toggle one of them, basically. And if he can toggle a new thing, he will toggle that new thing. Otherwise, he will do it with the first number. And initially, he starts all the numbers to be n. Initially, he turns all of the numbers to be n. And the point is that, guys, if k is even, if k is odd, you can just have n n's, right? I mean, that's okay. I mean, basically, this case k modulo 2 0 that we are considering is the main case. That's the main case of the problem. That the rest of it is not important, because if k is odd, you can just print all of them to be n. But if k is even, you have to toggle some of them. When n is 1, the whole point that exists is that you should make one of these ones 0, and you will try to make a new one 0 this time. Otherwise, if this was 0, you can start from the beginning and go forward, and for each, I mean 2 by 2, try to toggle the numbers to have that bit. If they did not have this bit before, because n does not have this bit. So so these numbers didn't have this bit, but now 2 by 2 you can change them from 0 to 1. That's actually the same solution, basically maybe a different way of implementation. I hope that it's clear. Yeah, I like this code. I mean, that explains why he accepted this so fast. Okay, guys. Anyway, so I hope that you enjoyed it. I have to now leave to do the tasks that we have to do right now. And I hope that you enjoyed it. We're gonna soon start the boot camp of DP Beatmask as well, which is our next boot camp that got the most votes. Even though later on, Graph got more votes, but at the end that we closed it, it was DP Beatmask. So, what about the n-2 approach? I checked Tourist Code to see that if he used that approach that you were saying or not, because he implemented it fast. So I was like, probably he used that solution, but he hasn't. But I think that that is intuitive. I don't see why it's. I mean, it depends on what you do with their last two numbers. If you just make one of them 0, then that doesn't work. Okay, I think that the solution that you have in your mind and you think doesn't work is that you make the last one 0, but that's not what I'm saying. I'm saying that the last two, you should see that how do you want to do that. This is not my solution, definitely, but I think that there is some potential in it and it can be correct. Thank you. Thank you, Dubs game. It doesn't work. 187. I'm glad to hear that it's helping. Thank you very much. We can play it. Yeah, there are some things that you can do, and I think, as I said, I mean the counter examples you mentioned that works as well. Maybe if I think more, I see that there's some issue with it, but in the short time that I thought about it, that looks good. Yeah. Okay, so see you guys soon in the boot camp and in the future solution discussions and many. And guys, if you like to do solution discussions on this channel, as you know, and as I also said it on Discord server and on Telegram channel, let me know. We are adding more people to have solution discussions because maybe I'm also on the code of the website and many other things. So I would love it if some of the solution discussions there will be other people who can do it as well. So let me know if that's something that you're interested about. And if your rating is candidate master and above and you're fluent with English. Thank you. Thank you guys. See you soon.